Once upon a time, in a land not too far away, there were these two programmers. One programmer, his name was Pete. And he was a pretty sharp guy, but he was stuck on a particular application that he was writing, and so he needed to talk to Penelope, who he felt was way smarter than he was when it came to programming, and he needed some ideas. See, Pete's problem was he had this really ugly formula that he needed to get into Python. So he turns to Penelope and he says, "Hey, Penelope." Penelope says, "Hey, what?" Pete says, "I have this really, really ugly program, or this ugly formula that I'm putting into Python as a program, and I am just having a real tough time with it. It's become very unwieldy. Let me show you my code." So he drug his code over on his laptop, and he said, "Penelope, right here, a string is equal to none. So I'm declaring my variables. A string is equal to none because we know that inputs from Python only give us string data or string types of data. So what I did was I declared all of the different variable strings that are going to be coming in, and then I made a corresponding variable that I would use to hold the cast to an integer. Okay, that is, I'm going to take a string and I'm going to cast it to an integer and store it into A. That's what my plan was. And of course, you know, by the virtue of the nature of programs, we're going to have a lot of declaration variables, which I understand. But down here in this section, this is kind of driving me a little crazy because I found that I'm repeating this block of code over and over again. I go through and I obtain the variable for the data for A by using an input with a prompt, storing the result in A string, and then casting the A string stuff into a variable called A, and then testing it to make sure that it's greater than 0 or is equal to 0 and greater, right? And if it's not, I'll send a message to the user saying that the number can't be negative, and then we'll go back through the loop. But if it is, it'll be done. I know that the data is in A, and we can move on to the next variable, which is B, all right? Well, this repeats, and as you can see, this has evolved into a fairly long body of code that only takes input. It's driving me kind of crazy because, as you can see, I have 148 lines of code already, and I haven't even got all my input stuff done yet. What kind of suggestions do you have for me, Penelope? I would really, really appreciate anything that you can do to help. Well, Penelope said, "Have you ever done a factorial program?" And Pete said, "Sure, I've done that. It's pretty much a straightforward program. All I did was collect input and used a loop to calculate the factorial, and then I gave output." And Penelope said, "Great. This is going to give us a wonderful stage for helping you to learn all about functions and procedures." Now, functions are available in Python, whereas procedures are not. The way that we know that something is a function is it will return a value, whereas procedures just simply do stuff. And you'll understand that a little bit more as we explain it, okay? One of the advantages of doing a function is this little body of code. Let me go ahead and bring that over for you. This little body of code right here, from here to here, can be turned into a function, and then we can write a single line of code that repeatedly uses this body of code to get the input for every single thing that we're working from. But before we can do that, before we can you can understand how all this is working, you need to kind of get the whole picture. So let's go ahead and dive into that factorial program of yours, and we'll discuss the whole picture. So here's a program listing of your no functions version of the factorial. Okay, what we did was we declared some variables to hold our data to begin with, right? We had the string variable to hold the user input as a string because, as I said earlier, inputs only give us strings, all right? And then we have a number right there that we will use to hold the information from end string when we cast it into an integer. That is, hold the integer result. And then we're going to have a variable that's going to hold the result of actually calculating the factorial. So we have an input stage, and the input stage basically said, done is equal to false, so we're not done. So while not done, get some input. and make sure that it's 0 or more, okay? And there's our little message that we're tinkering around with that I'm sure you've already played around with, from your big old giant program that you showed me. So there's the input stage. And then we have a processing stage where we actually calculate the factorial using a loop. We have an accumulator right here, which we'll call F. And then down here, we'll just use a loop and we will multiply equals, using that wonderful feature of Python to abbreviate our code a little bit. We will multiply it all out until ultimately we end up with F equals the result. And then down here, we output whatever the result is. So if F was 5, then we would see from here that it would say 5 factorial is equal to 120. So this is what you're used to. Now let's go ahead and let's break this thing down into what are called functions. Now the way that functions work is they ultimately involve a concept known as modular programming. And modular programming usually takes what is known as a top-down approach. So what does that mean? Top-down means as we look at the whole picture. Well, I have a program that's going to be doing, giving me what I want. So I guess what I'll do is I'll just call it main. I'll call it my main program. And main, in turn, will call a bunch of subprograms. All right. And let me go ahead and bring that up and show you kind of, in a printed version that looks a little cleaner than my handwriting, what main is all about. So let's go ahead and do that. So here it is. Here's the general layout of the landscape of our program. Okay. What we want to do is in Python, as you recall, in our line-by-line execution program that we did earlier, if there was a line of code in Python, it would execute it. So that's what we're doing here. We are creating a line of code right there called main, and Python will execute it, except for there's one tiny problem. Okay. There isn't a main. That function does not exist in Python. So we have to create it. And the way that we create that function is we use this syntax right here. We say def space main. And in our mind's eye, we're saying, yep, main is just simply going to calculate a factorial. It's going to get information from a user. It's going to do the whole enchilada. It's going to take care of everything for us. So then, exactly what is in main? What's in this function that we are creating? Well, what I did was I wrote the function from beginning to end, and here's where we're executing it right down here. Okay, and you'll notice the main is right up against the edge. Totally up against the edge. So in terms of indents, there are no indents, okay? When I define the function, I'm going to use the same kind of indentation business as you would with an if or a while loop or whatever. That is if we indent code, anything that is indented will be related to this. So I say def main to create my main function, okay? And in the main function, my mind's eye goes to the notion of what exactly do I want to do? Well, I want to get an integer, right? And if I get an integer successfully, then I want to find out what its factorial is. And then if I pull that off, then I want to print it, right? And so that's what I'm doing. I've gone from the complexity of zero complexity of just simply main being, hey, that's the program, to now main, inside main is I'm going to get an integer, I'm going to get a factorial, and I'm going to print it. But you'll notice that I haven't written any code to actually accomplish that, other than I said that argument, the variable argument, which I declared up here, it's currently set to -1. That's this up here, right here. Currently set to -1. And it's going to call a function that I actually haven't even defined yet, okay? And that function is called getInt, and it's expecting an argument called prompt, all right? And we'll talk about what prompt is in just a second, but up here I defined prompt as a message to the user, and the message to the user is going to be enter a positive integer. And notice that I made sure and put a little space there so that it would be a good user experience, all right? So same deal is happening down here. Result is going to call a function that I have not defined yet, Okay, I haven't created this. So if I tried to run the program right now, it would crash, right? So at any rate, it too has an argument right there. And that argument's going to actually be this value right here. It could be n, and I would put in the letter n here if I wanted to, right? I could say frog is equal to this, and here I would put in the word frog, whatever you want to use. And then once result is found, then I would call the last function, which is to print the results. Now you'll notice that my functions are a little different in operation. Here, I am executing a function and it's going to return a value and store it in argument. And I'm doing the same thing here. I'm executing this function, which will return a value, and it'll store it in result. Now, other programming languages, if you don't store the result anywhere, or you don't return any data, or you don't make any changes to data, such as just simply printing an output, then we actually call that a procedure. It goes out and it just does stuff for us, such as printing or whatever, okay? So this could be a procedure. In Python, we don't have a thing called procedures, so we use def for everything. And you'll notice that up here, I created a function called getInt with a prompt, a function called getFactorial, and then down here, a function called getResults. And you'll notice, okay, that my argument will be passed into this variable here, and it just so happens that they're the same value, all right? Some programmers don't believe this is a good idea because now we end up with variables inside of functions that have the same names as variables outside of the functions, and this can create a little confusion. Down here for argument, I used n. So on this side of the picture, the function itself, we have this, which will accept the value of our argument. This is called a parameter. On this side of the picture, we have again n, which accepts the data from this argument. So we have a parameter called n. And here we have two parameters. One of them is called n and one of them is called f. Okay, let's focus on getInt. You'll notice right away that I wrote a really nice set of comments for getInt. It tells me what the function does. And then it tells me what my parameter is, and I have a parameter called prompt, and I put little colon marks on either side so that I could easily delineate what the parameter, variable name actually is, and then a description of what it does. Okay, so it's a prompt supplied for the user. Here I have return, because I'm going to be returning an integer number. So I define def, getInt, and then prompt. And in here, I set n equal to none. Is a user-supplied integer is what n is going to hold, right? And down here I say done is equal to false. So this is going to be my loop control variable. And this is going to do the stuff that we're used to doing. I've literally taken my previous while loop for getting input, and I've just simply copied it into the function. But I added a little bit to it, okay? And you'll notice that this addition of stuff adds a keyword called try and another keyword called except. So this could be a little bit surprising for some of you. So what's actually in the try portion? Well, the try portion actually has what was in the while loop initially. That is I take n, I cast it immediately into an integer. So input, prompt, whatever I passed in as prompt, like enter value for a, goes here and is presented to the user. The user types in a value for a, it is then cast into an integer, and then it is stored into the variable n. If n is greater than a -1, then done is equal to true. I don't have to do anything anymore. Otherwise, the integer must be positive, try again. That is, send out the message, the integer must be positive, try again, and that means we're going to go back through this loop and we're going to do this again. What happens, though, if the user types in ASDF? Well, in previous programming assignments, programming experiences, if the user typed in anything other than a number, Python would crash. You would end up with red messages all over your screen, okay? Well, because we did this, we're telling the computer, hey, why don't you try this stuff right here? And if anything goes wrong, rather than sending a big old nasty message onto the screen and crashing my program, just go over to this little block of code called except. Now, I didn't supply any arguments with except because I want to trap every possible contingency, every possible error that could ever happen. I am going to catch it, and I'm going to stick it right into this, or I'm going to deal with it right here. And the message is going to be print unsuspected input, try again. Okay, so the person types in ASDF, the result is it prints unexpected input, try again, and then it goes back to the top of the loop and it goes ahead and it says, hey, input your data. And then down here, it makes sure that it's okay. And if it's true, then we drop out of the loop and life is great in River City. The beauty of try and except, these two guys here, the beauty of that is if ever you should type in anything that does not work, the computer, rather than crashing, will just simply go to this point here. And we call it an exception. Whenever we type in data that is, ASDF, when the computer is expecting an integer or whatever, the computer has a bunch of rules that it is expecting, okay? And if you want to break a rule, just like, wherever you're working, you would ask, hey, can you make an exception to this rule for me, please? Well, that's what we're doing here. We're making an exception. We're saying that, hey, go ahead and try and cast this thing to an integer. But instead of crashing, let's make an exception. Hand the message off to me and let me deal with it. Okay, that's the exception to the rule that you have. And the rule is I'm crashing. Here, the exception is let me print something out. And so it does it. Get integer, then once it succeeds, it will return the value. And the end value, whatever is here, will get pushed into down here, get factorial, define function get factorial. So in the main, we have, say, like x equals get, I'm sorry, not get factorial, get integer. And let's say that I even put the word prompt in quotes. Okay, so it prompts the user, gets the integer. This function then will return the result into that value right there. So hopefully that makes sense. Okay, now that we have get integer defined and we've written the code for making this happen, let's go ahead and let's look at get factorial. And get factorial basically says we have a little parameter called n, which is going to expect the number. And that number is going to be used to actually figure out the factorial. So if n, if I called get factorial, if I said x is equal to get factorial 5, then 5 would get stuck into n, and we would run through this loop. And the result would be is that f would then be equal to 120, and it would return that value 120 and store it into x. That's exactly what would happen. So this is the processing part of our program, and it's pretty straightforward. Now that we have the processing portion done, we did this, now we can print the results. Pretty straightforward. And all it does is it's just a convenience kind of a function, or in this case, it's actually a procedure, okay? It's a convenience kind of a function in Python that will accept our original number and the results of our calculation, and it will give me formatted output. And the formatted output is going to basically say 5 factorial, if n was equal to 5, is equal to 120. And that's pretty much all there is to it. So if we take a minute and review the main body of the function, we see that we have in main a nice roadmap of what's going on. We're getting our input, and that's all it's doing. Okay, we're doing our processing, and that's all it's doing right through here. Input and then processing, and then finally we're getting our output, and that takes care of business right there. This is why it's so important that when we're tinkering around with our programming or when we're writing code, that we divide our code up as much as we can. Input, processing, and then output. Okay. Another thing that's really, really important whenever we're writing a function is do as little as possible with each function. Functions should do only one thing. If they have to do more than one thing, then you're going to write a function A that will call function A and A B. So we'll be calling two functions if it's going to be doing two things. I'm hoping that that makes some sense. Okay. So the last thing I want to point out is whenever we have something going on in a program where we're calling a function or where we're executing a function, we call this a function call. So we're going to call a function. And in most cases, the function is going to return a value that we'll want to store in a variable. In some cases, it will not.